equation. The parameters IDSS and VP, VP means sometimes it is also called as VT or VGS off also, okay, are generally given by the manufacturer. If it has been given by the manufacturer, then here this makes things a little easier where the Q point can be calculated. Okay. However, we have to note that here IDSS is a function of temperature, and both IDSS and VP are strongly functions of the manufacturing process. So it is therefore important that for the manufacturer data sheets, here you have to know what is a Q point where it is being obtained for the safe operational conditions. Okay, operational conditions here. Now, next, to operate in the linear region, here to operate in the linear region, or here then it is a flat curve. It's just a flat curve. In case if it goes beyond or if it exceeds this region, then it goes off to breakdown region. In the breakdown region, the JFET just rushes and increases of the ID in milliamps. So we can see in the graph it is increasing, then flat, and then again suddenly shoots up. Hence we can define the JFET transfer characteristics as ohmic region, or the region where the FET behaves like a resistor. Next, pinch of voltage where we get it, and in the ohmic region, at the end of the ohmic region we get a new voltage, of course. Next, at the start of the saturation, or that is where we exactly get the Q point, there the pitch of voltage can be found, and you get the faithful amplification. And finally, the in case if the voltage is beyond, that is if the VDS voltage is beyond control, then it goes to breakdown region. So these are the regions of operation where JFET can be represented as a transfer characteristics. Next, moving on to the application, there are some important applications of a JFET where the JFET can be used as a constant current source. It can be the JFET can be used as a buffer amplifier. It can be used as an electronic switch, phase shift oscillator, high impedance wideband amplifier, and JFET is used as a voltage variable resistor or voltage development resistor. In short, it is called as VVR and VDR. It can be used as a chopper. It is used for high input impedance amplifier, okay, and so on. So till here what we have discussed is all complete related to JFET. Next, just moving on ahead, we go in for MOSFET. MOSFET is another topic where if you have understood the JFET fundamentals very well, then it is very much easier to go in for MOSFETs. The MOSFET is called as the metal oxide semiconductor field effect transistor, is another category of field effect transistor. The MOSFET, different from the JFET, has no PN junction structure. Instead, the gate of the MOSFET is insulated by the channel by a SiO2 layer, that is the silicon dioxide layer. Two basic types of MOSFET are enhancement type MOSFET and depletion type. Of course, in enhancement type of MOSFET and in depletion type of MOSFET, we have both for N channel and P channel respectively. Hence, we can have the bifurcation as N channel enhancement type of MOSFET, P channel enhancement type of MOSFET. Similarly, N channel depletion type of MOSFET and P channel depletion type of MOSFET. The enhancement MOSFET is more widely used comparatively to the depletion type. Okay. Here, because why it is widely used is because of the polycrystalline silicon is now used as a gate material instead of a metal. These devices are sometimes called insulated gate FET or IGFET. Just knowing this, the introduction of a MOSFET, will just go in directly for the working principle of a MOSFET. Next, coming into the working principle of a MOSFET, the main aim of the MOSFET is to control the voltage and the current flow between the source and the drain. Hence, it works almost as a switch. Switch is like on and off. The working of a MOSFET depends on the MOS capacitor. Capacitor in the sense like charging and discharging. If it is charging, it is in the on, and if it is discharging, it is in the off condition. The MOS capacitor is the main part of the MOSFET. The semiconductor surface at the semiconductor here at the semiconductor surface below the oxide layer is located between the source and the drain terminal. It can be inverted from P type to N type by applying a positive or negative gate voltages. Remember, we can switch over from one type to the P type to N type or from N type to P type by applying the gate to source voltages. So here it can be inverted from P type to N type by applying a positive or negative gate voltages. Hence, we tell gate is the controlling terminal. When we apply the positive gate voltage, the holes present under the oxide layer with a repulsive force and holes are pushed downward with the substrate. If a voltage is applied between the drain and the source, the current flows freely between the source and the drain. If freely between the source and the drain, and the gate voltage controls the electrons in the channel. Instead of positive voltage, we apply negative voltage, then a hole is created in the channel, with a whole channel will be formed under the oxide layer. So the representation is here of the MOSFET. Okay, now having known the working principles of a MOSFET, we slowly move on to the regions of operation. In the regions of operation, usually MOSFET is operated in three regions, namely the cutoff region, ohmic or linear region, and saturation region. In the cutoff region, here the MOSFET will be in the off state. If I tell in the off state, then no current will flow through it. Then if there is no current flowing through it, obviously it will act as an open switch. And because why did I tell it as open switches? Because we already saw in the introduction that MOSFET can act as a switch also. So it acts as an open switch and it is used as electronic switches. The next region of operation is ohmic or linear region. In this region, in ohmic or linear region, here it will act like a resistor where it will give the faithful amplification, and it can be used as an amplifier only if and if the current between drain to source, that is IDS, increases with the increasing of VDS. VDS is voltage of drain to source. This region is used as amplifier. Moving on to next, that is the last region, is the saturation region. In the saturation region, here IDS is constant by increase in VDS, and once VDS exceeds the value of the pitch of voltage VP, the device will act as a closed switch. So to summarize here, in the regions of operation, we know that the MOSFET acts as a closed switch in saturation, whereas open switch in cutoff, whereas it can be used as an amplifier in the ohmic region or the linear region. Okay, thank you.